Hi all, welcome to my getting started guide on the Dynamo car wheelbase generator script for Alias. It's just a short video to get people started on how to use the script. So the first thing that you will do is download the script somewhere on your hard drive. Click on the Dynamo button in the transform tab here and invoke Dynamo. Make sure that the status is connected here like that, and then your main Dynamo window here. Now the first time you run the file, you'd obviously go to open and find the file and then run it. In my case, I'm just going to click on the recent history here and start the script that way. One thing to note is that the script is actually wired up to write data to Alias straight away. So if you're working on a live project, just make sure that you've got a blank layer picked here that you want to target the data to, but in my case I've just got a new alias window with the default layer. So I'm just going to move the Alias Dynamo windows out of the way for a second just to show you the geometry that's been output. The first thing that you might do is pick all the geometry and turn off the CV and hull and edit points for a cleaner view, and maybe shade it up, that way you can see what's going on. Now this script is mainly targeted for concept artists, and for a few good reasons too. A, it's quite tedious to accurately draw a wheelbase from scratch based on engineering criteria, and B, the script actually draws some very useful graphics on the screen that can actually help to guide you in placing your lines and getting the proportions correct and getting your design looking as good as possible, really. So the key features for concept artists to note is that it actually draws a golden spiral from the front of the car to the back of the car, and as concept people you probably know the value of the golden spiral. I don't need to go through it here. The other thing to note is that where the wheelbase is, it actually has split that in two here, so you can see the midpoint of the actual wheelbase, axle to axle. There's also a few arrows here. Up here you can see that it's actually divided the length in four, so you've got a rough guiding as to what the halfway point is, quarter, 3/4, etc. And likewise there's some arrows for the third markers as well. So basically from the front of the car to the back of the car you've got third markers. The other thing it has is an indicator for the height of the car. That's this rectangle here, and this is all controllable from the script. And you've also got some indication, some guide as to where the wheel arch is, etc. Just purely for guidance. I mean, the wheel arch may not be exactly here, but the script actually draws a default just to give you an indication of the wheel arch. Now the other thing to note is that the front of the car and the back of the car is indicated by these rectangles here. Now some of you might have actually deciphered that these rectangles are actually number plate sizes, and I've used three number plate sizes here, which actually covers most of the world's sizes of number plates for road cars. The ones that I've used is the UK one, the US one and the Japanese one, and there's quite a few other variations from other countries, but generally speaking they fall within the bounds of the three that I've drawn here. Now I've got one at the front and one at the back. Now moving on to the actual script itself, the script is actually live and it's got a live link to Alias, so anything that you change here it will change inside Alias. So right here on this blue box, I mean, this is what the whole script actually looks like. It's quite big, but on the left here you've got the input data, just a few pieces of key input data, and on the right here in this pink box you've got the output data, which is the stuff that gets written to Alias, and this purple box I'll talk about later, that's actually for Blender users, and this orange box shows some useful statistics. So with those boxes out of the way, all of the green boxes, or the groups I should say, because they're actually grouped up, they're actually pretty well labelled. So if you wanted to look through the script and try and work things out, I've made it as easy as possible to actually do that. So they're groups of calculations. So this one, for example here, this big one, is responsible for drawing the golden spiral. This one is responsible for the wheelbase length graphics. So the input data, you can see, is really easy. You've got your main wheelbase length here, which you specify in millimeters. Front and rear track width. Now I've actually separated those out because on some cars, especially sports cars, the front track might be different from the rear track width. That's the actual width from the center of the wheel to the opposite side center of the wheel. So it's basically the pivot point of the wheel. The distance between the pivot point to pivot point is the track width, and the same for the back, except the back doesn't really have a pivot point as such, except where the actual axle joins to. I've also separated out the front tyre size and the rear tyre size. Now these are specified in your standard notation for normal road car tyres, which is basically the width of the tyre in millimeters, and the wall height of the tyre is specified as a ratio. So in this case it's 30% of 265, and the rim size is specified in inches. That's pretty standard for road cars, and I've separated those out for both the front and the rear tyres, because again, some cars, especially sports cars, have a bigger tyre at the back than at the front. I'll talk about this rear tyre on ground in a second. Now the front overhang from axle and the rear overhang from axle will actually push these number plate indicators forward or backward depending on how far you go, and that would dictate the overall length of the car. And the vehicle height draws out that rectangle there, which you can also see in the preview in the Dynamo window here. Ground clearance specified in millimeters, I've got 110 here, and this is the bit that actually specifies the gap from the tyres to the wheel arch, so you can tweak it here if you want to. Now the default values which I've got here is actually the LaFerrari specifications. I've had to use some numbers to get people started. I just chose LaFerrari, and so this is basically the technical data, most of it for the LaFerrari. So just to show you that it's all 100% live, I'm just going to change the rear tyre size, for example, and just make it something really dramatic and obvious, and like make the rear rim like 30 inches in diameter, and then I click out and it just redraws it. Now you can see that the wheelbase length indicator has actually shifted to actually show the front to the back position. It's pretty cool, and I'll just get that back to 20. I'm going to click out and it all goes back to normal. Now the rear tyre on ground, I just wanted to talk about that briefly. As a concept artist, you'd probably want all of the tyres to touch the ground, basically, to have that grounded look. So if this is set to true, then all the tyres will be touching the ground. Now if this is set to false, what happens is that the wheelbase is actually drawn straight on from the front axle, straight on. That means that if you had a bigger tyre, it would fall below the ground level, which you can just see happening here. Now this would probably be the way that a technical CAD drawing is actually set up, but as a concept artist you probably don't want that. You want to have a more realistic look, so that's why I've added this rear tyre on ground. And if it's true, what it does is it actually rotates the rig using the center of the front wheel as a pivot point, and it rotates the whole rig until the rear tyre touches the ground. And this is all live, so no matter what tyre sizes you have, you know, this will all be calculated, and it uses a bit of trigonometry to actually perform that calculation. Because if you think about it, the point from here straight across to here and then up, joining the center of the back wheel, actually forms a very thin right angle triangle. So you can use trigonometry to work out the amount that the rig should rotate for the rear tyre to touch the ground. So that's quite cool. Okay, just want to talk about the data in the orange box here. It's basically just a bunch of useful stats, like the total car length, which is always useful. Say for example your concept had to target an exact length, then you could set your wheelbase length, which is defined by engineering, and then define your front overhang and rear overhang till you've achieved the target length that you want. And there's some other useful information. This one here that shows the number of degrees that the rig has to turn to make the rear tyre touch the ground. It's quite useful. So I'm just going to shoot over to the other side of the script. Now, sometimes you're not going to be doing all your concept work in Alias. I actually use Blender to do a lot of concept stuff, and in which case I rely on the STL export feature that Dynamo has here, export model to STL, and that exports whatever geometry you can see in the Alias window here. All of that geometry will get exported. Now the problem is that lines, splines, curves, whatever you want to call them, they don't get exported to STL. STL doesn't recognize that stuff. So what I've had to do is, in the script, I've had to create some additional geometry that isn't output to Alias, but it is available inside the script, that actually converts some of these lines, like the golden spiral and stuff, to solid geometry. And because they are geometry in Dynamo, they'll get exported out as very thin geometry that look like splines, but they're not splines, they're actually 3D objects. And it's just a guide. Once you've got it loaded up in Blender, you know, you'll just see it as a very thin line, and you can use that as your guide to start sketching. I actually use grease pencil in Blender, which is really a cool way to actually do concepts. So if you do use Blender to do your concept work, then I've got a few notes here that I've added to help you get the model into Blender once you've exported the STL out. So if you use these settings inside Blender when you import the STL, then the model will actually come in at the right place, at the right position as you see it here in Alias. Now for engineering purposes, the model is usually expected in this location, where the front axle is on the y-axis and the length of the car is in the x-axis, and the front wheel is touching the ground. and so the script will actually handle all of that stuff. So if you actually change the size of the front wheels, change the size of the back wheel, it'll all redraw so that the axle is always here and the front wheel is touching the ground, and the golden spiral and everything will actually redraw. So that's basically the script in a nutshell. So this is version 1 of my script. I've got a couple of ideas of what I want to do to improve it in the future. I was thinking of doing something with a 95th percentile mannequin that actually gets drawn in with the wheelbase, that you can use the script to actually define the position of that mannequin and the hit point, etc. To really help you to work on the packaging side. If you're one of the curious types that wants to explore the script, I just want to give you a couple of notes about the way that I've laid it out. Now, I've tried to do it in such a way that is as easy as possible to decipher. I mean, it's not always a straightforward thing to work out somebody else's code and maths and stuff, but if you do want to decipher it, you might want to go to view and change the connector lines to the curves type, which is actually the default one. The curves is default, and if you have it set to curves, it just helps you to trace lines a little bit better. You know, if you click on one, then it actually draws the connecting lines in blue, and it just helps you to trace where the lines are. I only had it set to polylines because the script is easier to view, you know. The curves just look messy, but they're easier to help decipher. But really, if you're not into trying to work out the script, this blue box is really all you need. Very simple. The orange box shows some stats. The pink box is the output data, and this purple box is additional geometry that gets exported for STL purposes. That's really the script. So just load it up and start messing about with these numbers and just have a play, and everything will update in the alias window. And it's much more easier than trying to draw an accurate wheelbase from scratch, or like use CAD or something like I used to do before to draw my wheelbase really accurately and then bring it into Alias or take it to Blender. It's just a much faster way to actually do things, and the more efficient you can be, the more you can focus on getting your concept work and your styling all nailed down. So that's the script. Thank you for your time, and hope you enjoy it.